Welcome to the DIY Honda Garage channel. The purpose of this presentation is to guide you through troubleshooting DTC P16E6, which indicates a malfunction in the transmission range switch, start switch circuit in the 2017 to 2023 Honda Accord. The diagnostic trouble code, DTC P16E6, can lead to issues with the vehicle's ability to start correctly and can cause the transmission to be unresponsive. The transmission range switch directly impacts the engine control module's ability to recognize the gear position of the transmission, essentially telling the vehicle whether it is safe to start. This switch is generally located on the transmission assembly and ensures that the vehicle only starts in the park, P, or neutral N modes. When this DTC is set, it typically implies that there is a circuit malfunction, which may involve short circuits, open circuits, or faulty connection points affecting the switch's operations. It is essential to follow a structured approach to resolve the issues indicated by this code accurately. DTC P16E6 signifies a malfunction specifically in the transmission range switch start switch circuit. This component plays a pivotal role in indicating the current gear position to the powertrain control module, PCM, allowing the vehicle to start only when in park or neutral modes. The transmission range switch is typically situated on the transmission assembly. Its functioning is critical, as incorrect signals can lead to starting problems or unintended vehicle movement. The circuit associated with this switch comprises various wires that may be exposed to wear or damage over time, making it crucial to check this wiring thoroughly. Receiving this DTC suggests that diagnostics should be performed to determine any faults present within this circuit, which may range from poor electrical contacts to complete switch failure. There are several potential causes for the DTC P16E6 condition. One major cause is a short circuit on the wire connecting to the transmission range switch, which can lead to incorrect readings or prevent the switch from signaling appropriately. Loose terminals or corroded connections can also impede the electrical current, leading to intermittent or complete failure of the switch circuit. The transmission range switch itself may also be faulty, causing it to malfunction or not function at all. Running through specific diagnostics can help isolate these issues. By understanding these causes, technicians can more easily target their testing and repairs, ensuring a smooth resolution to avoid future recurrence of the diagnostic trouble code. Symptoms associated with DTC P16E6 can severely affect vehicle operation. The most prominent symptom is that the vehicle may not start at all, resulting in inconvenience for the driver. Additionally, there may be issues related to the responsiveness of the transmission, meaning it might not shift properly or behave erratically due to the lack of accurate gear position feedback. Usually, the check engine light will illuminate, signaling that there is an issue that needs to be addressed. Understanding these symptoms allows drivers to recognize when to seek professional help and inform technicians about the specific issues they are experiencing, thus speeding up the diagnostic process. The first step in addressing DTC P16E6 involves verifying the problem. Start by turning the vehicle to the on mode, allowing the onboard computer systems to initialize. Following this, it is critical to clear any existing DTCs using the Honda Diagnostic System, HDS, which helps create a clean slate to accurately assess current issues. After clearing, shift the transmission to a position other than park or neutral, and maintain that position for at least 5 seconds. This maneuver may help reproduce the error condition, and it is essential to check for any confirmed or pending DTCs after this process. If DTC P16E6 shows up again, it indicates that the failure has not been resolved, and warrant further investigation into the electrical circuits or mechanical components involved. In the second step, turn the vehicle to the off-lock mode to ensure a safe working environment. Once the vehicle is completely powered down, disconnect the transmission range switch 10P connector. This connector houses essential wiring for the transmission range switch, and testing will yield insights into any potential failures. To check for continuity, utilize a multimeter and assess continuity between specified test points. The test points consist of the female terminal number 7 of the transmission range switch, 10P connector, and body ground. Continuity indicates a complete circuit, whereas a lack of it could point to shortcomings within the wiring or bonding points, leading to the DTC being triggered. For the third step, shift the transmission to a position other than park or neutral again to ensure the switch is in a different mode. Disconnecting the transmission range switch 10P connector is necessary once more for this check. Use a multimeter to check for continuity, this time between test points consisting of male terminal number 7 and male terminal number 1 on the transmission range switch side. An affirmative continuity would suggest that the switch is functioning minimally, which points to needing a replacement. Should there be no continuity, a thorough inspection for any poor connections or loose terminals at the transmission range switch itself or the PCM, powertrain control module, must be conducted. Validating their integrity is crucial to eliminate them as potential fault sources before replacing the switch or PCM. In the fourth troubleshooting step, use the HDS to jump the SCS, service check signal line, allowing for a deeper diagnostic approach. Wait for more than 1 minute after this jump to ensure that any transient conditions have stabilized. Following this, disconnect the PCM connector E, 80P, setting the stage for further continuity checks. With the transmission range switch 10P connector still disconnected, assess the continuity between PCM connector E, pin number 67, and body ground. Finding continuity indicates a fault in the wiring, ATP-ST, ATP-ST wire, between the PCM and the transmission range switch. Repairing this wire is vital, as it directly affects the circuit causing DTC P16E6. If no continuity exists, the ATP-ST, ATP-ST wire is intact, prompting further investigation into service information or considering substituting the PCM to see if that resolves the DTC. After completing all repairs related to DTC P16E6, it is essential to verify the effectiveness of those repairs. Start by clearing all DTCs from the system using the HDS. This procedure should reset the vehicle's diagnostic monitor and eliminate any previously stored error codes. Next, conduct a test drive under varying conditions to ensure the repair has resolved the original issue. Monitor the DTC status closely during and after the drive, paying special attention to any symptoms returning. Confirmation that no new or pending DTC appears signals that the repairs were successful. A thorough individual check like this is crucial in the troubleshooting process, as it validates the performance and reliability of the repair undertaken. Preventive maintenance is paramount in maintaining the integrity of the transmission range switch and avoiding future DTC P16E6 occurrences. Regularly inspecting the wiring harness for any signs of wear, fraying, or damage is essential to prevent short circuits and disconnections. Visual inspections can help catch potential issues before they escalate into expensive repairs. Additionally, checking all electrical connections for corrosion can significantly enhance reliability, as corroded terminals can lead to weak signals or intermittent failures. Scheduled servicing of the transmission range switch ensures that any contaminants are addressed promptly, preserving its functionality. By adhering to a preventive maintenance regimen, vehicle owners can prolong performance and avoid inconvenient breakdowns. In conclusion, understanding DTC P16E6 and its implications within the 2017 to 2023 Honda Accord is integral to maintaining vehicle performance. Recognizing symptoms such as starting issues and transmission responsiveness will prompt timely action. By following a systematic troubleshooting approach, beginning with problem verification and moving through continuity checks, you can effectively identify and resolve the underlying issues linked to this code. Performing repairs correctly and routinely checking the associated wiring and connections can help ensure that the vehicle remains reliable and roadworthy. Lastly, adherence to preventive maintenance practices will guard against future occurrences of DTC P16E6, keeping your Honda Accord running smoothly and efficiently. Please like and subscribe to the channel. See you next time!